Every RAG tutorial you've watched uses the same setup. A folder of clean PDFs, maybe a Wikipedia dump. You chunk it, embed it, throw it in a vector store, and the answers come back beautiful. Then you point that exact same pipeline at a real company's data, and it falls apart within a week. I've watched this happen more than once, and the reason isn't the model. It's not the embeddings. It's not your chunk size. It's something much more boring and much harder to fix. Here's what enterprise data actually looks like. A warehouse management system running for 15 years. 400 tables. Column names like userdef1 through userdef20. Each one repurposed 3 times by 3 different implementation teams, none of whom documented it. Business logic living in stored procedures, not in the data. And the same customer existing under 4 different IDs because of a migration in 2017 that nobody fully finished. Now someone in leadership asks, can we put a chatbot on this? The honest answer is yes, but not the way the tutorials tell you. Let me walk through the 4 things that break in the order you'll hit them. The first failure is the most fundamental, and it's baked into how RAG works. Retrieval finds text that is semantically similar to the question. In a clean corpus, similar usually means relevant. In enterprise data, it very often doesn't. Take a question like, why was this shipment delayed? Semantically, the closest matches will be every document that talks about shipments and delays, which in a logistics company is essentially everything. Thousands of near-identical records, all scoring roughly the same. Your top K retrieval returns 5 of them, effectively at random. The answer the user actually needs might live in a single exception record with no delay language in it at all, just a status code and a timestamp. This is the core mismatch. Similarity search assumes the answer looks like the question. Enterprise questions are usually about relationships between records, not about the content of any one record. And embeddings don't encode relationships. Second problem, and this one is invisible until it bites you. When you chunk a document, each chunk carries its own meaning. When you chunk a database row, it carries almost nothing. A row saying status equals SHP underscore HLD with an ID and a date is meaningless in isolation. Its meaning comes entirely from the schema around it. What table it's in, what it joins to, what that status code means in this specific implementation. Embed that row and you've embedded noise. Teams usually discover this after their first evaluation round, and the fix everyone reaches for is enrichment. Flatten the joins, expand the codes into English, write a natural language description of each record before embedding it. That does work. But notice what just happened. You now need to encode the business meaning of every status code, every user-defined field, every table relationship, by hand or close to it. That knowledge often exists nowhere, except in the heads of the people who've supported the system for years. The hard part of enterprise RAG isn't the retrieval pipeline. It's the documentation project you didn't know you'd signed up for. Third, and this is the one that actually kills projects, enterprise systems have row-level access control. A regional manager sees their region. A finance user sees costs. A warehouse operator sees neither. The moment you embed everything into a single vector store, all of that is gone. The index doesn't know who's asking, and a retrieval system will happily surface a salary figure or a supplier contract to whoever phrases the question right. There are real fixes here. Per tenant or per role indexes. Metadata filtering applied before the similarity search, not after. Post-retrieval authorization checks against the source system. Every one of them costs you something: index sprawl, latency, or complexity. But the version where you skip this and add security later doesn't exist. Once the index is built, the boundaries are already gone. This is usually the point where a pilot that demoed beautifully gets stopped by a security review. Fourth, and it's the least discussed, documentation is mostly static. Enterprise operational data is not. Inventory positions change every few seconds. Order statuses move continuously. A vector index built on Monday is describing a world that stopped existing on Monday. So you need a re-embedding strategy. And embedding is not free. At enterprise volume, it's a real, recurring compute cost, plus the pipeline to detect what changed and re-index only that, which raises a question worth sitting with. If the data changes constantly, and the answer needs to be current, is retrieval the right pattern at all? Often the honest answer is no. For live operational questions, a text-to-SQL approach against the live system, or just a well-designed query tool the model can call, beats RAG outright. RAG is for knowledge, not for state. Now, none of this means enterprise RAG doesn't work. It means the naive version doesn't. What actually works, in my experience, is narrower than what gets pitched. Scope it to genuine knowledge, policies, procedures, documentation, historical case notes, support tickets, content that is text-shaped and slow-moving. RAG is excellent at this, and most enterprises have enormous untapped volumes of it. For anything about current operational state, give the model a tool that queries the live system instead. Retrieval for knowledge, function calls for state. Most of the failures I've seen come from a system trying to do both through one mechanism. And invest in the metadata layer early. The enrichment work, encoding what your codes and fields actually mean, is the highest leverage thing you can do. And it's the part every timeline underestimates. The uncomfortable summary. The difficulty of enterprise RAG is almost entirely proportional to how badly documented your systems are. The AI part is close to solved. The data part never was. Next video, I'm going deeper on that metadata layer, specifically why your database schema turns out to be the hardest part of any enterprise AI project and what to do about it. If you work on these systems, I'd genuinely like to know which of these four you hit first. Leave it in the comments.